All right, welcome back everybody. Today we're going to focus on using our skills now for right triangles and trigonometry in order to solve right triangles. So what does that mean? When you are asked to solve a triangle, so that key word there is solve, you are being asked to find everything that is missing. So you will always be given three pieces of information, either two sides and an angle or two angles and a side. So that means you have to find the other angles and the other sides that you don't know. And so it means three calculations. It doesn't always mean you're going to use trigonometry, though, to find all of the missing numbers. Sometimes they're quicker, more efficient ways of doing it than using trigonometry. So I'm going to point out some options as we go through these examples to show you that no matter what you decide to choose, as long as you keep your decimal places proper till the end, you should end up in the same place in the end anyway. So let's get to it. Notice that we have two 90-degree triangles in these diagrams that are given to us. In this first triangle, again, we're being told to solve the following triangle. So that means find everything that's missing in it. So we have triangle ABC. It's already labeled for us. We're given little a. So remember, little a is opposite capital A. So little a is 3. Lowercase b is 2. Lowercase c is an unknown. We also don't know angle B, and we don't know angle A. So I'm going to call angle B theta. So I'm going to put a theta symbol in there. So again, remember, theta is just that, looks like a 0 with a horizontal line through it. And I'm going to put another symbol for angles. So I'm going to put alpha in vertex A to indicate that corner. So what we're going to do now is we're going to now go through and try to find these three missing numbers. The order you find them in doesn't matter. So we can go for little c first, we could go for theta first, or we could go for alpha first. It really won't make a difference. Sometimes it's easier to go through to get one before the others, but in this case it doesn't make any sense. One doesn't stand out. So why don't we go for theta? Why don't we go for that one? So I'm going to tell the reader for theta dot dot. So I'm telling the reader that that's what I'm aiming for, angle B. So if you didn't call it theta in the diagram, you'd have to keep calling it angle B. So again, that's the way you write it, the little angle symbol and capital B. So either one is fine, but don't call it theta if there's no theta in your diagram, because people won't know what you're referring to. So for theta B dot dot, or so for angle B, or for theta dot dot. Now, in perspective to theta, what do we know? I know the number 3, and I know the number 2. The number 2 is across the triangle, so this is considered to be opposite. The number 3 is adjacent or next to the next to the angle, so it helps form the angle. Remember, C is the hypotenuse, so these two cannot be the hypotenuse. So this side's the opposite because it's across the angle that I'm interested in. And the number 3 is the adjacent. So something that has opposite and adjacent in it. Opposite and adjacent. So again on my sheet. So TOA. There we go, just to remind myself. Opposite and adjacent, tan. So this is a tan situation to get theta. So I'm going to write my formula. Tan of the angle, not tan equals. Tan of an angle, in this case called theta, equals the opposite divided by the adjacent. So I don't know the theta part, so that's going to stay as is, but the opposite is a 2 and the adjacent is a 3. So that's me now subbing in my numbers. Now I'm going to show my solution step. My solution shows the tan being kicked out to the other side, so I get theta all by himself. Now when we put tan on the other side of the equation, he becomes inverse tan. So he has a -1 exponent on him. So we say inverse tan. Inverse of whatever 2 divided by 3 is. Whatever that fraction was that was sitting over there. So now to get your answer, you go to your calculator, and I'll remind you, you always verify that you are in degrees mode. So in my calculator, I go 2 divided by 3 first. I get that decimal. I don't round, and I don't write it down. Nobody cares about this number. This number isn't important. This number isn't the angle. It's whatever 2 divided by 3 is. So we're trying to find the angle that creates an opposite over adjacent side that is worth 0.666666, repeating. So this isn't 0.7. This isn't 0.67. So we're not rounding. We keep everything here, and then we go second function or shift, then tan, and that's what gets us into our inverse. And after you press equals to 1 decimal place, usually for angles and sides, 33.7 is what we would call this angle. So 33.7 degrees. So he's done. So I think he's 33.7. Now that I know that this angle, this 33.7, I can find angle A, or alpha, next quickliest, because I don't have to use trig, although I could. So I'm going to show you 2 ways to do it. So for alpha dot dot. So option 1 would be to use trig, because maybe I don't trust this 33.7 number. So I'm going to pretend that I don't know this number. And I'm going to now redo the question that I just did, but now angle A is my perspective. So now this becomes opposite. Where the 3 is now opposite. And where the 2 is now adjacent. So it's still going to be opposite over adjacent, or tan, just like it was before. So tan alpha equals opposite over adjacent. Tan alpha equals 3 over 2. Again, kick out the tan inverse of whatever 3 over 2 is, and I'll just finish it up there. So exactly the same question, but now the 3's on top and the 2's on the bottom, because now I've changed my perspective. This is now considered opposite. This is now considered adjacent. So again, in your calculator, 3 divided by 2 equals 1.5 in this case. Don't write it down. Nobody cares about that number. Inverse tan, 56.3 degrees. But I know many of you are saying, why did I bother doing all that work when I know that the angle sum of a triangle is always going to be 180 degrees? So if I trust that this corner B is 33.7, and I already know that this corner is 90 because the picture tells me, I can very easily find out. So option 2, if you didn't want to do all this work and you wanted to trust this previous answer, you would then write alpha equals 180 minus out the 90 minus out the 33.7. So that's you showing your work. So 180 degrees, take away the numbers that you know, and you can verify on your calculator that you're going to end up with your 56.3, same answer that we got using trig. So it shouldn't give you a different answer, right? It's the same triangle. So this just verifies that we were correct in our theta answer, because that's why alpha worked out to be the same answer as when we didn't use theta. Now we found B, corner B, we found corner A, so the last remaining part is C. So again, I'm going to tell the reader, for little c dot dot, we have choices. So again, I can pretend that I don't know these numbers, and I can just base it on what the picture gives me. Because in this case, I have enough information to do small side squared plus small side squared equals longest side squared. Right? So option 1, again, not basing it on anything I've previously found, 3 squared plus 2 squared equals c squared. So again, small side squared plus small side squared always equals the longest side squared. So what do we get? 9 plus 4. This is 13. Once we square root 13, we'll get our answer. So 3.6 to 1 decimal place. Now the other option, if you didn't want to do this, you could now use, for instance, 33.7 degrees. We can't use the 90. So we can trust this answer, and we could say, oh, we could do opposite to 33.7 and hypotenuse, for instance. Or we could do adjacent to 33.7 and the hypotenuse. It won't matter because I know each of those numbers, so I could do sine 33.7, and again it's sine because opposite and hypotenuse is a sine situation. Sine 33.7 means using the 2 on top of the c, right? Opposite over hypotenuse. I'm interested in the c, so the c has to come up, and whatever was sitting there goes down. So c equals, the 2 doesn't get touched, sine over 33.7. Again, use your calculator. 2 divided by sine 33.7, and you get your 3.6 answer. Now, again, just to show you, option 3, if you didn't want to use the 2 and the c, again, we could have done 3 and c. So adjacent and hypotenuse, adjacent to 33.7 and c. So adjacent and hypotenuse, this becomes a cos question. So cos 33.7 equals adjacent, which is 3, on top of hypotenuse, which is c. So again, the c is on the bottom, which is what I want, so he comes up. 3 doesn't go anywhere. On the bottom then gets kicked out the cos 33.7. And again, try it on your calculator. 3 divided by cos 33.7 is again 3.6. So you can see that it didn't matter how we attack this question. We didn't round, and that's why we got the same exact answer in all cases. Now, in these situations where you have to find multiple things, it's always good to summarize. Therefore, angle B or theta is 33.7 degrees. Angle A or alpha is 56.3 degrees. And little c is 3.6. So it's always good to summarize your answer. Normally, if I had space, I would have done it down here, but I didn't have any other space. All right, so I showed you a lot of multiple choices here, options. Obviously, you're only picking one, so you're not doing a question twice, right? This one I did it 3 times. You don't have to do it 3 times. You're just picking one and sticking with that. But I'm just showing you that there's no one way to do any of this. So that's good. So you can think differently than other people and still get to the same final destination in the end. So in this triangle, which is HJG or GHJ, we're missing G and H, and we're also missing angle G, which I'm going to put again the theta symbol in there because there's no theta. I know angle 25. So again, it doesn't matter if I find theta first, if I find G first, or if I find H first. I think most of you are probably going to get this corner first. So for angle G, dot, dot, angle G equals, because you know the other 2 numbers, so angle G equals 180 minus 90 minus 25 degrees. So 90 minus 25 gives you 65 degrees in that corner. I'm not going to do it any other way. That's done. So I know this corner is 65. I can add it to my diagram if I need to. Now, I can now find either G or H. I'm going to go back and use the 25 number because that was given to me in the question. I'm going to use the 13. The 13 is the hypotenuse, right? Because it's across from the 90 degrees. So because it's the longest side, I know it's the hypotenuse. So 25 degrees hypotenuse and G. G to the 25, which I picked because maybe I screwed up in this answer. So I'm just going to go back and use a 25. G is adjacent. So something that has adjacent and hypotenuse, opposite isn't important in this particular situation. Adjacent and hypotenuse is cos. So for little g dot dot, what do we say? Cos 25 degrees equals adjacent, which is G, over hypotenuse, which is 13. So now the part that I'm looking for happens to be on top, which means I just need to kick out the 13. 13 times cos 25 equals little g all by himself. So what does that mean? In your calculator, you can do the cos 25 part first, equals, don't write that number down, the 0.9063 number, and you're going to times that by 13. And we're going to get 11.8 to 1 decimal place. So now that I know that side is 11.78, Notice that I rounded this. This isn't the exact answer. 11.8 is rounded. So keep that in mind when we go for little h. Because if I did g squared plus h squared equals 13 squared, which I could, I'm going to be using a rounded answer, this 11.8 number, to find this answer. So this answer might be a little bit off because of that. So if I want to avoid that, knowing that I'm using sort of an inaccurate number, I'm going to go back to trig and base this now on the 25 and opposite. So the h is opposite to the 25 and still the 13 that came in the question, which is hypotenuse. Opposite and hypotenuse to the 25, opposite and hypotenuse. This is a sine situation. So sine 25 equals opposite, which is h, over hypotenuse, which was the 13 number. Kick the 13 up to the other side. 13 times sine 25 gives you h all alone. In my calculator, I do the sine 25 first. I press equals, I get that decimal, and then I just go times 13, which again to one decimal place, 5.49 is 5.5. So if you had tried this squared, so 13 squared minus 11.8 squared, and then square root that, 5.45. So instead of 5.49, which is what this was, if you had done Pythagorean theorem, you would have gotten 5.45. So in the end, you probably still would have rounded to 5.5, but you might have been just a little bit off there if you didn't round. So let's summarize. Angle G was 65 degrees. Little g is 11.8. No units were given in the question. And little h is 5.5. Okay, so we found all the parts that are missing. So again, only 3 calculations required for 3 missing parts. All right, so let's see this situation. They gave us a picture over here. When it says that it's not drawn to scale, what that means is you don't actually take a ruler or a protractor and you start measuring stuff. You're not going to get the correct answer. So during its approach to Earth, the space shuttle's glide angle changes. When the shuttle's altitude, so the altitude means height, so height is always 90 degrees to the ground. See the 90-degree corner? When the shuttle's altitude, okay, so I'm just going to redraw it here. So shuttle, S, G for ground, is 15.7 miles. The horizontal distance to the runway is 59 miles. Okay, so R for runway. I don't know. What is its glide angle? So the glide angle, it's the angle of depression. So really, it's asking you for this. But you notice how this angle out here is outside the triangle? So what happens is we can zigzag it, right, using alternate angles because this and this line are parallel to each other. So you see the Z pattern happening here. And because of the Z pattern, this amount here, which is the angle of depression, right, how the angle that the plane is coming down at to hit the runway, that's going to be this angle over here. It's going to be the same measure. So we might as well just find this one if we're really looking for that one because they're the same number. So we have this situation now. I've labeled my corners, S for shuttle, G for ground, R for runway. Could use ABC if you wanted. I know that I'm interested in this bottom corner, not this upper corner. Don't care about that one. And I'm going to base everything now on this. So 15.7, that's opposite. The 59 to the angle that I'm interested is adjacent. And it wants us to keep one decimal place in our final answer, so the nearest tenth. So something that has opposite and adjacent is tan. So tan theta equals opposite over adjacent. I don't know theta in this case. The opposite is 15.7. You don't have to write miles. The adjacent is 59. And again, miles on top of miles cancels out. Again, we kick out the tan to the other side. So we inverse tan of whatever 15.7 divided by 59 is. So again, in your calculator, you figure out the decimal first, 15.7 divided by 59. Don't write that number down. Don't round it. Don't call it 2.66 or 0.266. Go Shift tan, second function tan, while it's all still in your calculator, and then press equals, and you'll get 14.9. So the pilot knows that he's descending at an angle of 14.9. Therefore, the glide angle, whatever it's referring to it as, the glide angle is 14.9 degrees. All right, there's another part. When the space shuttle is 5 miles from the runway, its glide angle is 19 degrees. Okay, so that means horizontally, I'm assuming, because that's the way it was referring to it. Should have specified. So, again, situation, shuttle, ground, runway. So when the shuttle is 5 miles away, its glide angle is 19 degrees. So he's coming down at 19 degrees. Find the shuttle's altitude. Okay, so that's what we don't know. We don't know how high the shuttle is above the ground. Round your answer to the nearest tenth. So because, again, we know the shuttle above the ground is 90 degrees to the ground. We know that it's a horizontal distance of 5 miles. We know now the angle in this case. We can zigzag this angle and put the 19 that was out here, which is the angle of depression, to 19 in there, which now is inside the triangle, which is more useful. Again, we have opposite that we're interested in, altitude, and adjacent is given. So we need to use opposite and adjacent in this question, which is again another tan situation. So tan 19 degrees is opposite. I called it X on my triangle. You could have called it little r. You could have called it H for height. Anything you wanted. So as long as whatever you're referring to in your solution is actually part of your diagram. So X for me, opposite over adjacent, which is 5. Kick up the 5. So 5 times whatever tan 19 is gives us X all by himself. Tan 19 equals times 5 equals 1.72. So to the nearest tenth, 1.7. So therefore, what is it asking us for? Find the shuttle's altitude. Therefore, the shuttle's altitude is 1.7, and in this case, miles high. Sure, off the ground. All right, so that's it for that question. We don't need that diagram anymore. All right, so now we're on this final one, a different situation. It says, during a flight, what do we have here? We have 2 people. A hot air balloon is observed by 2 people standing at points A and B. The angle of elevation of point A is 28 degrees, meaning the person standing here, their height is irrelevant. That's why they're just a dot on the ground. For them to look up to see the hot air balloon, the elevation angle is 28 degrees. So we'll put that in the diagram. And then point A is 1.8 miles from the balloon as measured along the ground. So from here to there. So for them, from standing underneath the balloon over, they said that they're 1.8 miles. So not the whole thing, just from point A over. What is the height of the balloon? So height, as you know, again, is always 90 degrees to the ground. You know that it makes a 90-degree angle, altitude and ground. So in this case, let's label this A, B, C, D. So all the points have been labeled now. We are now focusing just on this triangle, triangle ACD. That's a right angle triangle. We don't care about anything over here right now. So an angle in triangle ACD, we need to know the opposite, which is the height, and we are given the adjacent. Opposite, adjacent. Hypotenuse, not important. So opposite and adjacent, it's tan. So tan theta equals opposite over adjacent. Tan 28 equals h over 1.8. Kick up the 1.8 because the h is already on top. And that's going to give us our h by itself. So tan 28 equals times 1.8 distance, 0.96 to the nearest tenth. Well, the nearest tenth, if you look at rounding, the 7 makes that 5 round up, the 5 makes the 9 round up. That's the 10th position. So this is going to be 1.0 when we're done. Therefore, the balloon is 1.0 miles high. Okay. Now there's this person B though. Point B is 2.4 miles from point A. So the whole thing, these two people, point B is 2.4 miles away from point A. Find the angle of elevation. So how high up does this person need to crank their head? Now they're standing much closer, as you can see in the diagram, than point A is. So because they're standing closer to the balloon than point A is, they should have to have a bigger angle, right? Because you have to really look up the closer you are to something that's tall. So I'm expecting this answer to be bigger than 28 just before I even start the question. So in order for us then to know point B, so if I just carry out my diagram here, this is point B and I want to know that angle, I can figure out, this is C and this is D, I can figure out this amount down here by just going the whole distance minus out this distance, which should give me this distance, right? So 2.4 minus 1.8, 2.4 minus 1.8, 0.6 of course. So I know that distance there is 0.6. Okay, so from there to there is 0.6. So because I know that's 0.6, I don't know any other numbers in this triangle on its own. I have to bring down the number that I just got in my previous answer. Now keep in mind this 1.0 was rounded. If you remember, it was 0.957 something. So I would suggest you use the actual number to be super accurate instead of using 1.0. But I know many people are going to just use their final answer from over here. But just so you know, you might be off by a decimal place. So we can check that later. So again, opposite and adjacent is what I know. What I'm looking for is theta. This is again another tan situation. And you'll probably realize tan is used a lot. So in this case, theta is what I'm missing. Opposite is 1. Adjacent is 0.6. Kick out the tan to the other side. 1 divided by 0.6. So 1 divided 0.6 equals inverse tan, 59.0. So 59.0 degrees. So that is the angle of elevation. The angle of elevation of point B is 59.0 degrees. Now, what if we didn't use 1, right? The rounded answer. I'm going to go back here and get all those decimal places back in my calculator. So tan 28 equals times 1.8 equals, so that's 0.957, the previous number that we got before we rounded to 1. So I'm going to just in my head replace this numerator with that, divide it by 0.6, and now shift tan, 57.9. 57.9, very different than 59.0. So that's showing you If you keep all your decimal places like you're supposed to, instead of using rounded answers, your answer carried forward will be different. So again, 1028 equals times 1.8 equals, that's 0.957 number, divided by 0.6 equals, shift 10 equals 57.9 degrees, versus 1 divided by 0.6, shift 10, 59 degrees. So we're over 1 degree off, just because we carried forward a rounded answer. So that's something to watch out for. So you're using a rounded answer. Therefore, final answer will be off. So that's what happened there. So because we use this rounded answer of 1, it made our final answer of 59.0 off. This is the actual, when I actually didn't use the rounded previous answer. So again, I'm trying to show you that in trig, it's important that you carry forward every single digit right up until the end, so you can report back the actual final answer. All right, till next time.